there's an object floating through our solar system that shouldn't behave the way it does. Its name is 3I/Atlas, and during its passage near the Sun in 2024, it did something no comet had ever done before. Its brightness skyrocketed millions of times beyond expectations. It accelerated without apparent reason and displayed characteristics that contradict everything we know about these celestial bodies. The astronomers who observed it found no satisfactory explanations. Some data simply doesn't fit with known laws of cometary physics. When scientists pointed their telescopes at Atlas, they expected to see a typical interstellar comet, an icy nucleus losing material as it approached the sun's heat, forming a predictable tail. What they got was something completely different. The object changed color, its tail pointed in impossible directions, and its brightness fluctuated in ways that defied any computational model. There were moments when researchers questioned whether they were actually observing a natural phenomenon. The Atlas story began in December 2019, when the Atlas telescope system in Hawaii detected a faint point of light moving rapidly among the stars. At first, it seemed like an ordinary comet, perhaps one of the thousands populating the Oort cloud. But when astronomers calculated its orbit, they discovered something unsettling. Atlas wasn't orbiting the Sun like other comets. Its trajectory was hyperbolic, which meant only one thing. It came from outside the solar system. This made it the third confirmed interstellar object in modern astronomy history, after Oumuamua in 2017 and Comet Borisov in 2019. But while Oumuamua was a fleeting mystery that vanished before we could study it properly, and Borisov behaved like a conventional comet, Atlas promised to be different. Its orbit would take it dangerously close to the Sun, at just 0.25 astronomical units, roughly Mercury's distance. Scientists prepared to observe the spectacle. But where exactly did this interstellar visitor come from? Trajectory calculations revealed that Atlas originated from the direction of Sagittarius, a region of space that had already captured astronomers' attention for disturbing reasons. In August 1977, Ohio's Big Ear radio telescope detected an extraordinarily powerful radio signal coming from that same zone. The signal lasted 72 seconds, was 30 times more intense than cosmic background noise, and never repeated. Astronomer Jerry Eman, upon seeing the printed data, wrote "Wow" in the paper's margin. Since then, the WOW signal has remained one of SETI's greatest enigmas, the search for extraterrestrial intelligence. That Atlas came precisely from that region of space, more than 4 decades later, seemed too specific a coincidence for some researchers. But science requires evidence, not speculation. Telescopes focused on the comet as it approached the inner solar system. As Atlas drew closer to the Sun during the early months of 2024, its brightness began increasing. This was completely expected. Comets brighten when solar heat vaporizes ice from their surface, releasing gas and dust that reflect light. Models predicted a gradual, moderate increase. What happened was radically different. Within weeks, Atlas went from being barely visible with professional telescopes to shining with an intensity that exceeded all predictions by a factor of millions. Its apparent magnitude shifted from 19 to potentially 5, meaning it could become visible to the naked eye from Earth. These types of brightness outbursts had been observed in some comets, but never with this magnitude or speed. It was as if something inside Atlas's nucleus had suddenly activated. Astronomers reviewed their data looking for measurement errors. There were none. The brightness was real, but the physics behind it made no sense. For a comet to increase its luminosity that way, it would need to expel massive amounts of material. But Atlas's nucleus was estimated at only a few kilometers in diameter. Expelling enough mass to generate that brightness should have completely disintegrated it. Yet Atlas remained intact. Then something even stranger occurred. The comet's color began changing. Comets typically reflect light in reddish or orange tones due to the organic dust they contain. Atlas, however, turned blue, not a faint blue, but a deep, intense blue that spectrometers confirmed again and again. This bluish tone suggested unusual chemical composition, possibly with abundant carbon monoxide or cyanogen. But those components should have evaporated long ago in an object that had been traveling through interstellar space for thousands of years. What kind of comet changes color while accelerating toward the sun? The answer to that question became more complex when observatories began detecting the next phenomenon. Atlas was accelerating faster than the sun's gravity could explain. This type of non-gravitational acceleration had been observed before in comets, caused by the rocket effect of gases expelled from their surface. But the magnitude of Atlas's acceleration was disproportionate. Calculations indicated the force acting upon it was between 10 and 100 times greater than a typical comet of the same size. To generate that acceleration through outgassing, Atlas would have to be losing mass at a rate that would consume it completely within days. Computational models couldn't reconcile the observed acceleration with the object's survival. It was a fundamental contradiction. When Atlas reached its closest point to the Sun on May 31st, 2024, space telescopes captured images that left scientists baffled. The comet's tail, which should point away from the Sun due to solar radiation pressure, showed chaotic structure. But most disturbing was the anticoma, a projection of material pointing directly toward the Sun, something that violated basic expectations. Anticomas aren't completely unknown. Some comets develop them temporarily due to perspective effects or the release of heavy particles that briefly fall toward the Sun before being pushed away. But Atlas's anticoma was persistent, changed direction without discernible pattern, and showed structure too defined to be an optical illusion. Light polarization analyses revealed another anomaly. When sunlight bounces off a comet's dust particles, it acquires certain polarization that scientists can measure to determine the size and composition of those particles. Atlas showed negative polarization at certain wavelengths, a phenomenon virtually non-existent in known comets. This suggested the particles in its coma had unique optical properties, possibly due to geometry or chemical composition we'd never encountered. Detailed spectroscopic observations uncovered another puzzling feature: stratified chemical envelopes. Atlas's coma wasn't a homogeneous cloud of gas and dust, but a series of concentric layers with different chemical compositions. One layer contained mainly carbon monoxide, another cyanogen, a third water. These layers appeared to have been released in distinct episodes, as if something inside the nucleus was controlling material release sequentially. This type of chemical stratification has been observed in some long-period comets, but never with this geometric precision or complexity. Models suggested Atlas's interior must have an unusually complex structure, perhaps with different volatile reservoirs separated by refractory material barriers. But explaining how a naturally formed object in the interstellar medium could develop such structure was a significant theoretical challenge. As Atlas moved away from the Sun after perihelion, astronomers expected its activity to gradually diminish, as happens with all comets. It didn't. Atlas maintained abnormally high brightness levels for weeks, suggesting it continued expelling material at a rate that should have depleted its reserves. Mass loss calculations indicated the nucleus should have lost between 30% and 50% of its original volume during the perihelion passage. To put this in perspective, Halley's comet, one of the most studied, loses approximately 0.1% of its mass in each pass near the Sun. Atlas was losing hundreds of times more material in a single encounter. If it continued at that rate, it wouldn't survive more than 2 or 3 orbits. But Atlas wasn't in a closed orbit. Its trajectory would carry it back to interstellar space. Or perhaps that wasn't its original intention. In July 2024, when Atlas crossed Mars's orbit heading toward Jupiter, observatories noticed its trajectory showed small deviations from purely gravitational predictions. These deviations were consistent with previously observed non-gravitational accelerations, but there was something peculiar about their pattern. They didn't seem random or purely reactive to solar exposure. They had certain directionality, as if the object were adjusting its course. Scientists proposed various explanations. One possibility was that Atlas had a rotating nucleus with asymmetric gas ejections, producing a precession effect, subtly altering its trajectory. Another theory suggested the object might be slowly fragmenting, with pieces breaking off that altered its center of mass and angular momentum. But there was a third explanation some researchers whispered in private conversations, though rarely put it in writing. What if Atlas wasn't simply a comet? What if it was something more? The idea wasn't completely far-fetched if all the data were considered together. An interstellar object that accelerates without clear cause, changes color, shows stratified internal structures, maintains activity beyond what's physically possible, and seems to adjust its trajectory. Individually, each anomaly might have a forced natural explanation. Collectively, they painted a disconcerting picture. The boldest hypothesis suggested Atlas might be an artificial artifact camouflaged as a comet, perhaps a reconnaissance probe from another civilization using outgassing as a form of propulsion. This idea had theoretical precedence. In 1960, physicist Freeman Dyson proposed that advanced civilizations could use modified comets as spacecraft, leveraging their ice as fuel for sublimation engines. Oumuamua, the first detected interstellar object, had generated similar speculation due to its unusual elongated shape and inexplicable acceleration. Harvard astronomer Avi Loeb even published a scientific paper arguing Oumuamua might be an artificial solar sail. The astronomical community mostly rejected that hypothesis, favoring natural explanations, though they admitted some of Oumuamua's features remained without satisfactory explanation. Atlas presented even more pronounced anomalies than Oumuamua, but the scientific community was reluctant to speculate publicly about non-natural origins. The reasons were understandable. Extraordinary claims require extraordinary evidence, and suggesting artificial intelligence without definitive proof could damage professional reputations. However, some data remained deeply unsettling. NASA and ESA had directed several of their most powerful space telescopes toward Atlas during its perihelion passage, including Hubble and James Webb. These observations were expected to produce unprecedented resolution images of the comet's nucleus, allowing determination of its exact shape, surface structure, and detailed composition. Those images were never published. Official statements mentioned ongoing calibrations and complex data analysis requiring time. But months passed, and no high-resolution images appeared in public astronomical observation databases. This was unusual. Normally, space observatory data becomes public after an exclusivity period for principal investigators, typically 12 months. In Atlas's case, that period had already elapsed. Conspiracy theories began circulating on amateur astronomy forums and ufology sites. Had the images revealed something space agencies didn't want to make public? Did Atlas show artificial structures? Was there evidence of non-natural geometry? The absence of information only fueled speculation. Reality was probably more prosaic. It's possible the observations didn't produce usable images due to technical limitations. Atlas was moving rapidly near the Sun, making precise tracking difficult for the long exposures needed for high resolution. Or perhaps the images simply showed a typical irregular cometary nucleus, and scientists were more interested in spectroscopic data than photographs. But it's also possible space agencies decided to keep certain data under internal review if they showed genuinely anomalous features requiring exhaustive confirmation before publication. Astronomy's history is full of premature discoveries that turned out to be instrumental errors or incorrect interpretations. Scientific institutions are cautious, sometimes excessively so. In September 2024, Atlas crossed Jupiter's orbit and began its long journey toward the solar system's edge. Its brightness had diminished significantly, making it undetectable to amateur telescopes, but professional observatories could still track it. Orbital projections indicated it would follow a hyperbolic trajectory that would eventually carry it back to interstellar space. But before leaving the solar system, Atlas will make another notable approach. In 2027, its trajectory will bring it relatively close to Earth, at approximately 0.8 astronomical units. It won't be a dangerous encounter, but it will be the best opportunity we'll have to study it in more detail before it disappears forever into interstellar darkness. Astronomers are already planning observation campaigns for that encounter. Ground and space telescopes will coordinate to capture data across multiple wavelengths simultaneously. There's hope that more prolonged observations, less hindered by solar glare, will reveal details explaining the anomalous behaviors observed in 2024. Meanwhile, the scientific community debates what we actually learned from Atlas. Some researchers argue the object simply demonstrates that our understanding of interstellar comets is incomplete. These objects spend millions of years in absolute cold of interstellar space, subjected to cosmic radiation that can alter their surface chemistry in ways we don't fully understand. When they finally encounter a star's heat, they might behave in ways that solar system comets, conditioned by thousands of orbits, don't exhibit. Other scientists suggest Atlas might represent an entirely new class of object, something intermediate between a comet and an asteroid, perhaps a fragment from a planet's mantle shattered eons ago in another stellar system. Its stratified composition could reflect different layers of the original planet, explaining the sequential release of distinct volatiles. More exotic hypotheses also exist. Some researchers propose Atlas might be an extremely ancient comet, formed in the universe's early stages, when interstellar medium chemical composition was different, containing unusual proportions of elements that would explain its singular behavior. This idea is speculative, but doesn't violate any known physical laws. And then there's the possibility, however remote, that Atlas isn't completely natural. Not necessarily an artificial spacecraft, but perhaps a natural object that was modified or utilized by some ancient civilization. The boundary between natural and artificial may be blurrier than we assume when considering cosmic timescales and civilizations potentially millions of years more advanced than ours. This speculation isn't science in the strict sense, but it's part of the scientific process. Bold hypotheses, even improbable ones, serve to expand the conceptual space of the possible and motivate observations that otherwise wouldn't be conducted. If science history has taught us anything, it's that the universe is repeatedly stranger than we imagine. What we know with certainty is this: 3I/Atlas exhibited behaviors that challenge our current models of cometary physics. Its non-gravitational acceleration, extreme brightness changes, anomalous polarization, stratified chemical structure, and persistent activity represent, collectively, a set of characteristics no known comet had previously shown. Atlas reminds us the universe still holds secrets. Each decade brings discoveries that question assumptions we considered fundamental. Exoplanets, the Higgs boson, gravitational waves, dark energy, all were initially speculations that became observed reality. Perhaps Atlas is simply an extraordinary but natural comet, pushing the limits of what these objects can do. Or perhaps it's something more, something our current conceptual frameworks can't adequately classify. Time and future observations will reveal it. As Atlas continues its solitary journey toward the interstellar void, carrying its secrets with it, one question persists in the minds of those who studied it. What other marvels or mysteries await us in the dark spaces between the stars? If Atlas is an indication of the diversity of objects populating the galaxy, then our understanding of the cosmos is barely beginning. And if future interstellar visitors show similar or even more pronounced anomalies, we'll have to seriously consider possibilities that today seem like science fiction. For now, Atlas remains one of the great astronomical enigmas of our era. An object that arrived from interstellar darkness, challenged our understanding for months, and then returned to deep space's silence. Its legacy is a collection of puzzling data and a lesson in cosmic humility. We don't know as much as we thought about the objects wandering between the stars. Do you think Atlas is just an extraordinary comet? Or is there more to its story? What other mysteries do you believe interstellar objects might reveal about the universe? Share your thoughts in the comments.